Welcome to the Building Efficiency Resources Podcast, the Bearcast. This episode, we are rapping with Tony Lisanti from Integral Building and Design. He is a bear raider, but he's more than just a bear raider. He is a very experienced energy engineer that has dealt with all levels of the implementation of the energy industry in New York State. We're going to look forward to speaking with him about the future of electrification in New York State and broader throughout the country. Hey, Sandy. What's up, my brother? How you doing today?
I'm doing great, Chris. It's getting close to the holidays. I've been spending some time with my kids from New York, and I was just thinking that, you're going to be 2-on-1, one Detroit guy, two New York guys on you right now in a few minutes. So I hope you're prepared for that.
Yeah, a couple of softies, though. I ain't worried about you. So Sandy, I got some depressing news for myself. I went to the Lions-Bears game for my 40th birthday. It was 2 days after my 40th birthday in Chicago. My first time ever going to a game at Chicago at the Soldier Field.
Bears.
And man, the Bears just totally ate the Lions. You got those weird YouTube videos like, what if a lion fought a bear? Well, this time around, the bear just completely smashed the lion and ate him and ate its cubs. Man, it was bad. So anyways, your Giants did me a favor. Thank God.
Yes.
Your Giants beat the Green Bay Packers in order to give us a little bit of a cushion. But man, I'll tell you what, some of that early, energy for the Lions is looking a little bit stalled out. So we'll see.
Well, I mean, I think, teams have these games, By the way, that Giants game was extremely ugly, but I'm glad they were able to pull through for you. Yeah, I think that, I think great teams. I mean, look, the 49ers got thrashed not too long ago, and I don't think anybody's, writing them off. And I really wouldn't write the Lions off yet either. I think it's a very good, they're a very good team. And I think you should be excited about what's going to happen here soon.
Well, I appreciate your encouragement. It's a long season, they added that extra game. And so it's, you start off well and it's like 17 games, man. It's a long season. So we're heading into the home stretch. I am grateful for that. Giants, they got a chance to sneak in the playoffs? Probably not, right?
Probably not. I mean,
it's
not looking good. I think they're 5-8 now.
Yeah. Well, we'll see. I hope you go on a run. But so going into our news segment here, I wanted to kind of prepare us for our next segment with Tony Lisanti. By bringing up something that, like, in researching this, topic, because I knew we were going to have Tony on, I found something I totally didn't know about at all. Back in May, the state legislature for New York State signed into law a mandate that by 2026, all new construction buildings, with some exceptions, but up to 7 stories, have to be 100% electrified. No fossil fuel hookups throughout the entire state, not just New York City. The entire state of New York prohibits having fossil fuel equipment in buildings up to 7 stories, except for big commercial and industrial buildings. And then in 2029, all buildings of all sizes, except for a few exclusions, have to be done without fossil fuel equipment. This is going to be implemented through the Energy Code. And again, this is happening starting in 2026. So basically January 1, 2026. So you're going to build a house in Rochester, New York. It's got to be all electric. This was mind-blowing. I had no idea. Sandy, it's like, how are we not talking about this? Had you heard about this?
So there was some talk about this at Building NYC when I went. But, again, at that point, it was already, I think it was already a law in New York City, but was proposed with New York State. I was not aware that it was passed. So this is kind of shocking to me. I would say I have two bits of feedback on it. One, I mean, I think it's a good thing. It's a great thing for our profession and building performance professionals. I think it's not surprising that New York City led New York State this way. It seems to be the norm. And I would say I got to say 3 points is look out grid. Because it's about to get real in New York State, and this is part of a lot of what we talked about, and we're going to talk about with Tony in the second segment as well. But there's challenges to this, and I think it's all the talk of electrification is starting to become real, and I think this is just one small part of what we're going to see going forward. And I think it's time to get real about what the consequences are going to mean, what we're going to need to do as an industry to make sure this is successful. Again, we talked about this before. Are we ready to design heat pumps? In this fashion, are we ready to implement and quality install these systems the way they need to be? To be 100% or as close to 100% efficient possibility that they can be in order to not tax the grid and become a giant, be worse than what was here before. So, like I said, I think this is the tip of the iceberg. We're going to see tons more of this, but I do think that it presents a very unique set of challenges for not only the building industry, but, the HVAC industry. I think it prevents giant challenges for, our building performance industry. And we need to get lockstep and tight on this because 2 years is a short amount of time to make this all work, Chris.
Yeah, no doubt. I mean, like I say, it's almost like some of these new legislative rulings are happening at such a breakneck speed that even people like you and me who are like in the know, we don't even know about it. And so it's if you and I don't know about it, then your local home builders definitely don't know about it. And if your local home builders definitely don't know about it, then their HVAC contractors don't. And that is, we're going to have to get on with some education. So Sandy, I guess, sign us up for some 310 training out there in New York. We're going to have some business here, I think, with getting out there and training people how to quality assure the installation of HVAC systems, because we're going to need to know it here. That's the reality.
Yeah, and I think that's a good point, right? I mean, I think 310 is going to implement Giant in this, and I think that's going to be something that everyone's going to want to really be up to speed on because quality installation. I really think it's funny. I had a call with a customer yesterday about some HVAC design, and this is the one thing that I brought up with them, and they were like, you know what, Sandy, you're right. I'm like, I would consider doing quality install checks, Totally. And I explained to him all the reasons why, and he was like, you know what, Sandy, you're absolutely right. We are losing it between design, if the design is correct, but let's just assume the design is correct, but then we're losing it installation side, and I think that this quality install, this whole QI concept is going to become, gigantic, and 310 really gives you the tools to be able to do this at an effective and, pretty cost effective way. And I think it's going to be very attractive to both, builders and, raters to pursue this.
Yep. Well, Sandy, with that in mind, we're going to keep the news segment a little bit short, and we're just going to go ahead and roll into section number 2 of the cast with Tony Lasani.
Awesome. Can't wait.
Okay, so moving forward with section number 2 of the Bearcast. For those of y'all who aren't avid listeners, we try to bring on guests for section number 2 in order to talk about hot, pressing topics of the day. And as has been a recurring theme of the Bearcast and will continue to be a recurring theme, we're going to be talking about the move towards electrification in buildings. And today we have a distinguished colleague of Sandy and mine. We have Tony Lasani from Integral Building and Design. They are based in the Hudson Valley region. of outside of New York City. And Tony has been a QAD and ResNet trainer for longer than I have been. He's been in the industry, an old head. Tony, when did you, first of all, welcome. Thanks for coming and joining the cast here.
My pleasure. Thanks for having me.
Yeah. So, Tony, when did you first get involved with all this this HERS business? What year did you get going?
2002-ish.
Oh,
That's
man.
when I took my first building science course, and I think I officially became a HERS rater and got my stripes in early 2003.
Wow.
Okay. Yeah. So you got a good solid half decade or more on both Sandy and myself. And primarily, for the most part, your career in the HERS industry has really been focused on work in New York State and maybe surrounding states there in the Northeast. Is that right?
Correct. Yeah. I mean, our personal work is basically anywhere from the northern reaches of New York City up to the Adirondacks and maybe into central New York. We've done a little bit of work in Connecticut on the western, the western portions of Connecticut a little bit, maybe one or two in Mass, but yeah, pretty much up and down the Hudson River Valley. That's kind of our backyard.
Okay. And, Integral, obviously does energy ratings, pretty decent focus on multifamily, but also some single family work. Anything else that we should know about Integral and what it's up to recently?
Yeah, I mean, we do for selected projects, we'll do some HVAC design, we'll do some load calcs and duct layout, manual JS&D if it's the right project. More significantly and to the point, and I want to make sure that I make this clear. My partner Pasquale has been very involved with an organization called New York Geo, which is a geothermal ground source heat pump consortium in New York. They do some lobbying, they do some policy advocacy work to try to grow that industry and not just promote the industry, but Pasquale's put his money where his mouth is. He's actually been involved with the design and installation of some geo systems for multifamily projects, as well as a number of award-winning single-family homes, in the Hudson Valley. So that's it. We dabble in some equipment sales and monitoring work too, because some of these multifamily buildings. It would be really neat to capture the data on how well these buildings are operating at the dwelling unit level as well as on the central systems level. And he was able to engineer and put together some monitoring equipment for these buildings. So not the typical HERS rating company, but certainly HERS ratings are the core of the business. So
that's awesome.
Yeah, I'd say, HERS Plus, right? And you guys are kind of going into all different sort of tentacles of the sort of allied services. It kind of seems like you go where your clients go, which is one of the coolest thing that I think happens in this industry is for, if you put yourself out there as being really knowledgeable and reliable as an energy rater, it can open doors in all other different aspects of the construction field and consulting field. And what it goes to show is, you don't necessarily need to be an energy engineer in order to do all this stuff. You can be a really just expert level HERS rater who cares to learn more and kind of take the next step. That all being said, Tony, you are an energy engineer. You are an energy manager. So the reality is we talk about you here as a HERS rater. That's not the reason why we wanted you on the call. We wanted you on the call because you're a certified energy manager and an energy engineer with an actual degree and professional experience working for a utility on grid implementation prior to basically you going into this whole HERS field. Is that correct?
Partially, yeah. So guilty as charged. I am a mechanical engineer by academia and a CEM. But yeah, I did work for Con Edison in New York for 10 years on a couple of different positions. And I also, after leaving Con Edison and how I sort of entered into the HERS field, I worked for an independent energy company. So as sort of you talk about opening doors, sort of my good work at Con Edison allowed me to kind of get cherry picked to go work for an independent energy company where I was, essentially hawking hydrocarbons for a number of years. So I was involved with the wholesale gas and electricity market at its inception, especially the electricity market when it first opened up. So I was on the Con Ed side of things when the market first opened up. And then I actually went into that market as a participant in the early 2000s. So I was doing that work in parallel to learning how to be a HERS rater, which are two completely unrelated things, but it paid the bills. So.
Okay. And I mean, what brought you into the HERS industry? Why, so I think some people would say, wow, you got a mechanical engineering degree, you're working at this grid level. Man, you just decided that you really want to carry a blower door for a living? I mean, good grief. What were you thinking, man?
I know. So here's kind of the real story. A lot of the early energy services companies, the formal energy service ESCOs that were going to be selling electricity and natural gas in these new retail markets that the utilities were required to open up, many of those companies were actually affiliates of utilities themselves. So Con Edison actually spawned its own independent subsidiary company that was going to be a marketing company to sell energy back to their own customers that they were getting. And many utilities set up similar companies throughout the country. This wasn't unique to Con Edison. All the utilities on the East Coast set up affiliates that were going to be independent retail wholesale sales companies.
These were like energy brokers, Tony, like that type.
Correct.
Yeah.
ESCO is the proper term for it, energy services company that had to be licensed by the state to actually do scheduling and buy power in the wholesale market and then schedule it and then more or less inject it back into the grid. But there's billing and there's customer service and there's consumer standards that had to be upheld. There's a whole litany of things that goes along with it. But selling energy in itself, you're always looking for the value added service to go along with the energy, because the acronym Energy Services Company, well, those folks got the energy portion down pretty well, but where the services come from, right? And so a lot of those companies were partnering up with large, with the Honeywells of the world, or the large general contracting companies, or the large refrigeration companies, or lighting companies. And they were going in doing demand reduction. So they were reaping the benefits of selling the energy to the customer and selling them packages of services. Some of them might be energy performance contracts. We'll lower your demand charges by X by relighting your building, or by putting in premium efficiency ECM motors and all that good stuff. Okay, so I got into
the early 2000s, where there was still a lot of that I would call somewhat low hanging fruit was still there, right? Because at this point, I think a lot of companies have moved away from very inefficient lighting in buildings, and LEDs have become much more standard, or at least more efficient fluorescent packages with controls. But maybe in the 2000s, early 2000s, late 90s, that really wasn't necessarily the case. There was still a lot of savings to be gleaned with that. I'm not saying that there isn't today, but that was sort of, I'd say, almost like the golden era of being able to get in there and really basically, especially some of those demand charges like you're referring to, there was a real opportunity there.
Yeah, I mean, as a snapshot in time, this is kind of like a history lesson, right? Like, kind of reliving, history for, maybe for some of the folks that are not as mature as us, that are, in the HERS field at this point in time. But you still had a fair amount of buildings of all types, multifamily, residential, institutional, schools that were sort of halfway between the old incandescent, fluorescent, lighting fixture, and then the transition to LED. But more so, it was really a fuel switching. The other aspect of the energy services, was the fact that many buildings were still using oil, and gas was a big competitor. And at that time, natural gas was much more expensive than oil. But oil could be curtailed, and oil could be very, from an economic standpoint, very volatile, not just in fuel content volatility, but in price volatility. We've seen that. If you're old enough, you remember the gas lines in the 70s and the 80s and all that kind of stuff, right? And embargoes and, odd and even number license plates. Well,
and even just a couple of years ago, we were seeing those stickers on the gas pumps, right? That were, pointing at the guy who made all those prices go up. I don't know what happened to those stickers anymore. It seems like the prices have come back down. Obviously, that's gas. But as a surrogate to fuel oil, I'd assume that the two track somewhat decently in terms of cost.
Well, they do. I mean, and the reality is, they get into like an esoteric part of the conversation. Our economy is built on the hydrocarbon atom, right? And if you haven't woken up to that fact yet, that is a fact. We are a fossil fuel based economy. There is nothing in this country that does not work on fossil fuel. And we'll get to the point about electrification in a little bit. So the point is, for building owners, there was a period of time when they wanted to hedge their bets and have the ability to switch fuels. And so the conversion of their heating plant from oil, heavy oil to light oil, and then light oil to having dual fuel capability to switch between gas and oil to sort of hedge the fuel costs when they needed it. And then some utilities offered interruptible gas service, which is even cheaper yet, where the utility would essentially notify you within 24 hours, switch over to oil because we're going to interrupt your gas service because we need that gas elsewhere in our system. And there was a financial benefit to those customers that were willing to put up with it. So having lived through all of that, that's the service base, those heating plant replacements, chiller replacements, lighting replacements, motor replacements. So finally getting to the question, how did I become a HERS rater? Well, all of those services were pointed towards the large customer. The schools, the institutions, the Class A and B commercial office spaces, even some of the larger multifamily co-op buildings. What was being done for the single-family homeowner? Nothing. And I happened to be working for an ESCO that was more residential-based as an oil company that wanted to get into the natural gas and electric market, but they had a complete infrastructure already that catered to the single-family homeowner. In a fairly affluent area, Westchester County, New York, it's not, it's diverse. There's different income levels through Westchester, but it's a population of about 900,000 people. It's not a small neighborhood. And so they had services that dealt with indoor air quality, air conditioning, boiler replacements, all manners that they even had a home improvement division at one time. So I saw this BPI, Building Performance Institute ad that had Steve Thomas, the former host of This Old House, as their spokesperson. And I'm like, well, there has to be something to this. And so I started looking into it. I took my first building analyst class, and a half an hour in, as they're explaining stack effect, the light went off. Physics applies to a house. Can you imagine that? The laws of thermodynamics actually apply to a house in the building. And that was it. That lit the fuse. I was like, this is, I don't want to say easy, but I'm like, it's so understandable. And why we didn't realize this before, I was just like, I have to go after this. So that's literally how I got into it. So.
Okay. Well, we're appreciating the fact that you've joined the ranks here of us residential focused people and really in a lot of ways paved the way. For those who don't know, when BER got started as a business, we were actually based in New York State. My business partner, Uriah, and the founder of the company was living up in the Adirondacks. And, so Tony was definitely a colleague of ours at the very sort of genesis of BER getting started as a business. And so, really, everything you just told me there, about your background, Tony, what I guess I want to boil it down to everybody who's listening here is Tony knows how to calculate some BTUs. He knows about big numbers of BTUs and how they equate to dollar signs. And he also understands how to implement this not just on some larger scale projects like, larger multifamily buildings with central heating and cooling plants, but also in an industrial scale. But then also going back to his experience with the utility, I mean, you were involved with grid level management implementation projects. Am I right?
Yeah, we had I had a couple of hats that I wore there, over my career. But before working for Con Ed, I actually worked for an MEP firm for about 5 years. And we did a whole diverse bunch of projects. I mean, everything from single family homes to entire school buildings. We would design, mechanical, electrical, plumbing, fire suppression systems for a school building. And you want to talk about understanding how a building works. Think of a school and all the systems that are in a school. It has everything. It has shop classes. It has offices. It has commercial kitchens. It has stage lighting. It has locker rooms, right? Gym facilities. So when you design systems for a school, you kind of get to see all of it. We did a lot of retrofit work for schools, out on Long Island. Anyway, joining Con Ed, I actually worked, if you want to call it, in the repair shop for the engine room of New York City. So,
wow,
I worked in it was an old IRT subway repair facility that Con Ed bought in the 1950s. They filled in the pits and made a world-class machine shop. It was really one of only 3 or 4 in the entire country. TVA, I think Southern California Edison, and General Electric and Con Edison. They were the only ones that had like facilities of this size. So it was literally what could not be carried to the Bronx to be rebuilt in terms of power generation equipment. We went to the power plant and repaired it.
Wow.
And 13 base load and plants in and around New York City. So I've literally lived inside and repaired and rewound generators that generate the electricity that keep the lights on in New York City. Okay, so from there, apparently I had a good line of something where I was able to engage with customers, and Con Edison seemed to like that. So they put me into an account executive group that was a group designed to hold hands with their largest Fortune 500 clients. Because as you can imagine, with 5 New York City boroughs and Westchester County, if you're, say, a supermarket chain that has facilities in all 6 of those municipalities, who do you call when you have a service problem with Con Ed? You call the Westchester people for Westchester. So they would make us like sort of a more or less a point person for all of those accounts. We were divvied up by industry sector. But the cool thing about this was that for the first time in my life, I was getting paid to sit in a classroom for 3 months while they taught me everything about Con Edison. On one hand, I knew all about the power generation equipment and fixing valves and pumps and turbines and reblading turbines and metallurgy and failure analysis. I spent a lot of time doing that. But now they put a suit and tie on me, put me in a classroom, and I learned everything about their steam system, their high voltage transmission system, their lower voltage distribution system, the gas system, their rates and tariffs, the legal process, customer service, billing. It was really, it was almost like being put up in the, at a high altitude to see the way the company operates. And we had access to the executive levels in the company for any issues. So with that, once Con Edison deregulated and those ESCOs came in, they assigned us to work with these other companies to make sure that they played nice with Con Ed and Con Ed played nice with them, because there was a lot of money at stake in making the wholesale and deregulated energy market work. Okay. So I learned how the wholesale market for electricity and gas worked, as well as how it dovetailed in within Con Ed's territory. Okay. So that allowed me also to see how the grid within New York City operated. But as I migrated away from Con Ed into the role with the ESCO, I had to engage with something called the New York ISO, New York Independent System Operator, which is an independent grid operator, if you will, that used to be the New York Power Pool. So their whole reason for being in New York State is to dispatch electricity to meet the demand when it's needed. Literally like an orchestra leader sitting there with the orchestra sticks, conducting an orchestra. This generator's got to come up. This one's got to come down. They keep the lights on in New York City. But in the early 2000s, another layer was added to them. They also had to be the wholesale market for electricity. They had to create a market to buy and sell wholesale power so that ESCOs could buy on the wholesale market and supply their retail customers. And that came, with a tremendous amount of responsibility, because grid reliability, you think about it, New York Stock Exchange, if that goes down, the entire country's economy goes down, right? So getting power in and out of New York, not only within New York, was very, very important to the New York ISO. And so I kind of learned the nuances of how electricity flows in New York State, and it kind of flows in one direction, where things and terms like a load pocket come from, which are geographic areas within the state that are constrained by transmission lines, where there's only a certain amount of transmission that can come in, meaning they have to have their own sources of generation within those load pockets to meet the demand, okay? And all of this hasn't changed much in 20 years. Yeah, there's been some new generation, there's been some new transmission capacity, but not on the wide scale growth of generation assets and capacity and transmission has not happened over 20 years. It's been incremental.
So Tony, how much would you say that the demand, in your estimate, I mean, I know you're not going to have the exact number, but how much would you say the demand has changed in those 20 years, though?
It has changed, and actually, the peak demand in New York City has actually gone down slightly. So it used to be Con Edison would set a new record every, at the end of every July or beginning of every August, about 3 p.m. on a hot summer afternoon. Yeah. They would hit a new generation peak, and I think their peak generation was just something north of 13,000 megawatts.
Wow.
Okay, of power. The state's total is about 36,000. So about 1/3 of all the energy, yeah, exactly, is in New York, New York City. Okay, just New York City. I'm not even counting Long Island, right? The 5 boroughs of New York City and Westchester. Those areas.
And we could probably attribute some of those savings to things like, number one, I'm assuming that, there have been improvements in terms of, more efficient air conditioning systems and their implementation. I would assume that obviously lighting, has changed dramatically over the 20 plus years you've been in the industry now, to the point where, by and large, the day of the incandescent light bulb, 100-watt light bulbs, those are basically gone for all intents and purposes, especially in an area like New York City. I would assume, domestic appliances also have gotten, considerably more efficient over that time. Any other idea why, perhaps there's been some improvements?
Yeah, I mean, you're right on with that. So a lot of the federal mandates with efficiency standards on appliances and air conditioning equipment, lighting, and certainly our building codes, right? Our building codes, we've had some big jumps in efficiency in the building codes that, obviously on the heating end for New York, which is a heating dominated climate, but let's not discount the effect of air conditioning, right? So air conditioning standards, where there was none, and now, there's a federal minimum of, 14.5 SEER. That's those improvements cannot be underscored. So some of that, and incentive programs and demand side management programs that the utilities have implemented, because let's face it, if that load continued to grow unabated, the amount of infrastructure that a utility like Con Ed or any utility would have to put in the ground would be, not millions of dollars, billions of dollars. And where does that money come from? That money comes from our pockets. Utilities are the sort of this weird entity that no matter what they do, they always provide a dividend for their shareholders. Their rates never go down, and yet they're able to spread that money out over the rate-paying public. And many of the incentive programs that are in place, either through the utility or through an entity like NYSERDA, all come from utility rates, whether it's a surcharge on the rate or whether it's a special, I don't want to call it a tax, but something like the Citizens Benefits Charge. It's a tax. on a rate.
It is
Okay.
tax. You're right.
Okay. So, all of that stuff has helped contribute. So over 10 years, Con Ed's system peak hasn't grown, but yet we still have seen a tremendous explosion in construction, right? And we've seen a tremendous rollout of air conditioning. I mean, if you look back 30 years ago and you look at the amount of homes that had central air conditioning or even room air conditioners versus today, that continues to grow. Okay. And that, and now you roll up to the, 2023, 2024, where we have these mandates to clean up the grid by 2030, to go all electric building mandates, no gas cooking for new buildings, electric vehicle mandates, where New York and New Jersey and some of the surrounding states, you're not going to be able to sell a gasoline engine or a diesel engine vehicle. So they're mandating, electric vehicles. So all of that power needs to be met by generation. Okay. Whether it's renewable generation or sort of the old fashioned dirty stuff that nobody likes. But the reality is the electrons got to be generated from someplace. Okay.
Yeah, and Tony, really, that's what we brought you on here for. Is you had watched one of our podcasts or listened, a couple episodes ago about the implementation of the carbon index in Ecotrope, and some of the opportunities, I guess, to look at things from a carbon basis, and and kind of the I'd say the carbon index in a nutshell is that it definitely is encouraging electrification because it's looking at sort of a long scale basis of how the grid may be constructed in terms of decarbonization over time, having increasingly amounts of renewables within the electrical grid profile. And so, essentially, the nutshell of the carbon indexes in most areas of the country, you are going to definitely score better with an all-electric house comparative to a kind of standard home with gas appliances, gas heating, gas water heating, etc. And sometimes, in certain areas of the country, dramatically so. We looked at an example in Iowa. If you build sort of a business as usual house today with gas appliances, you're going to be scoring in the 150s or something like that, 130s on the carbon index versus somewhere in the 60s or 70s if you did the same home with sort of standard electric appliances. And so the carbon index is really going to be kind of pushing people to potentially kick the tires on going all electric. Builders are looking at things like the HERS index for ESG reporting, increasingly so. And, we can only imagine that over time, that as the carbon index gains recognition in the marketplace, that in fact, builders may start to recognize that the carbon index, in fact, is the metric that really matters. And if so, then it could be encouraging builders writ large to be going all electric so that their performance on the carbon index sort of more uniformly around the country really looks good. But it's, obviously the carbon index is it's nascent, it's in its infancy. That's not what's going to necessarily push people immediately to go all electric. But things like this, a law that was recently passed in New York State, which I wasn't even really. No, New York State.
Oh yeah,
the state of New York passed a bill that is going to require all electric new construction starting in 2026. It was fashioned off of an earlier law in New York City. So New York City sort of greased the skids, but this law, which I went and looked up the law here, and it's like, man, these bills, these are 1,000-page bills and stuff like that. I don't envy the people who have to vote on this stuff, but kind of like within this giant Senate bill in New York State, there's a relatively small section that says blah, 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 blah about carbon and decarbonization. Oh, also, in any new building, not more than 7 stories in height, except for really big commercial buildings. After 2025, it's going to be prohibited to install fossil fuel equipment in building systems. And then in all buildings after 2028. So I actually didn't even know about this until really I was getting prepared in order to talk to you today, Tony. But like, this is, to say it is groundbreaking is an understatement. Now, New York State may not be the first one to have electrification as a within its energy code, but Washington State, for example, Sandy and I have gotten very familiar with Washington State. Their version of the 2021 IECC all but forbids fossil fuels within buildings. It pretty much explicitly, at least prescriptively, it explicitly makes people go to heat pumps and heat pump water heaters in Washington State. Now, you can go a performance path that really, it's there, but it's not really available for all intents and purposes. But this is saying, with pretty much almost no exceptions, very few exceptions, that buildings, basically mid-rise and under buildings are going to be all electric starting in 2026. So that is, we're knocking on the door of only 2 years away. Again, there are a couple of exceptions, there's a couple of
manufacturing
specific
restaurants. Yep.
Yeah, there's a couple of specific, but really, I mean, again, we're in the residential field, right? We're HERS raters. We work with multifamily, single family, et cetera. So let's just think about it through our lens. This is a pretty big deal. The fact that if you're going to build a brand new cabin up in, Tupper Lake, up in the Adirondacks, it gets pretty cold up there in Tupper Lake. Guess what? You cannot have propane. You cannot have a natural gas. Well, you're probably not going to have natural gas, but you're not going to have fuel oil, and you're not going to have propane in that new home in Tupper Lake in 2026. It's going to be illegal. That is mind-blowing to me. I mean, I'm not saying it's a bad thing. I'm not. Here's the thing. BER and the Bearcast, Sandy I, we're not here to say things are good or bad. That's not our job. But I think it's important to bring this up because I haven't heard about this. ResNet, we were just at the ResNet conference. Did anybody hear about this?
No.
I didn't hear boop peep about this.
It wasn't talked. Listen, I'm here in New York, and I didn't even realize that this actually passed already. I know it's been talked about, but I didn't realize it actually passed. I know it passed in New York City because that was earlier this year in last year's news.
Correct. Yeah. The local law 154 of 2021, which basically banned a new gas hookups in New York City. But this is like, so New York City, it's like, don't get me wrong, that, it kind of makes sense. That sounds like New York City. That sounds like a New York City thing to do. And also there's a lot of bigger than 7-story buildings and stuff like that in New York City. So that's less of groundbreaking news to me. This is groundbreaking news that, my buddies who are HERS raters in Buffalo are going to be overseeing exclusively all electric buildings starting as of 2026. This is mind-blowing. And it will be the law now, and it also ties into some of the opportunities with the IRA. There's going to be some pretty deep rebates that builders will be able to tap into when it comes to, electrifying buildings. So there's definitely going to be some sort of federal carrots and probably some state-based carrots with NYSERDA and things like that. So the cost transition, let's keep the cost transition to the side. Let's not think about it in terms of first cost of the builder. It's definitely going to be a consideration. One thing that, if you listen to the last episode, one of my big, Sandy's big takeaways was that 310, HVAC grading is really, kind of the vanguard within the HERS industry. But one of the things that, we really talked about is that the designs aren't there. And especially maybe when it comes to, how to really design heat pumps to get the most out of them and make them the most efficient. man, there's just like there's stuff we don't even know, and we're just learning now, and we're like the wonk, right? We're all the nerds, and we don't even entirely know how these systems work. So, within 2 years' time, basically, we got to figure out how to implement this well, because the builder has to make sure they're not getting callbacks. They got to make sure that the systems are going to heat and cool, and people are going to have hot water, and I think we can do that. I think we can, but good grief. Think about all the people not really designing HVAC in new construction right now. It has to be, dare I say, 90%. Maybe that's too high, but I don't know. Like, in terms of like doing the design and then implementing design, not just like doing it and having the code official stick it in a file cabinet, but like manual J, manual S, manual D. But then even really for advanced heat pumps, it goes beyond that. You have to know more about these systems than just that stuff too. So, to me, this is like, oh my God, we have to really prepare the new construction community immediately for this, because I don't think that HVAC contractors are prepared for this. Sandy, what do you think about this?
Well, I think going back to our, last episode when we were talking about this, I think that, and you brought up, you went to a session that I didn't go to where they talked about heat pump, and we talked, you and I have talked a lot about heat pump optimization and all the intricacies with designing a heat pump, where if they're not designed correctly and, they're not the right equipment, how it could actually wind up costing more energy. And I think that's where this all spins. And I have a feeling that Tony's going to tell us about, the grid conditions and where we are and where we need to be. But I mean, I could see, I love the idea of electrification, but I'm very concerned with the implementation of it, because one, I don't think, as you said, HVAC contractors are up to speed, and there's a big disconnect, I think, between quality design and quality implementation, right? And installation, QI, right? And I think there's a giant disconnect. I've been involved with HVAC design for most of my career in this industry, and I mean, I can't tell you how many times we've done a great design on an HVAC system, go in the field, and it's nothing like it was supposed to be. And that's where we're going to get in trouble. Not the right size, not the properly modeled equipment, and then not the correct install. And now more than ever, I think this situation and situations, this is the beginning of a trend, right? We're going to see this throughout many different states as we're going. There's a lot of money behind it. There's a lot of push behind it. I mean, the president just signed a War Powers Act we talked about in the last episode so we can produce more heat pumps, faster, because we're going to need them. I mean, there's a lot at stake here, and I think that really, it's a great thing, but I think we got to raise the flag a little bit about, are we really truly prepared to implement this into modern building? I know Tony's team is, but is everybody? And that's the question.
Well, yeah, and it's like, I've seen it firsthand. Bear has been going around the country teaching HVAC grading trainings. And, in one area of the country, and I don't want to give too many details, but, one area of the country, a cold area of the country, let's just say that it both gets cold and it gets hot. And, it is an area of the country that is pushing towards electrification. And so, a utility program was, basically, promoting this community that was an all electric community. And we did our HVAC grading on this home, and the duct design was just so far off from being acceptable. I mean, I'm going to get nerdy here because that's just Chris Mack being Chris Mack. But, like this heat pump, this air handler was like 1.2 inches of water column of external static pressure. And if you don't know what that means, that ain't good. That's bad. That is not a good amount of external static pressure. Now, it was an ECM system, but, there's a misconception that these systems are panaceas and that they're going to solve all of our problems. The air handler alone in cooling mode was pulling over 700 watts. And so there's no way that system was meeting its nameplate efficiency. I think the nameplate was like 19 SEER, which looks great, sounds good. But, the system just wasn't anywhere near designed or installed properly in order to obtain that. So, here's my thing. It's like, so we did some scenarios in the CO2 index episode a couple of times back, where we looked at the cost for the consumer going from gas systems, sort of rank and file, 95% gas furnaces, power vented water heaters, that kind of a thing, to decent heat pumps, maybe not the best, but like builder grade heat pumps, and just electric resistance water heaters. Well, why would a builder do that? Why wouldn't they get a Mitsubishi, or Fujitsu ducted system and a heat pump water heater? Well, because builders are cheap. Now, I hate to tell you, but builders are in the business to make money, and there's nothing wrong with that. I'm just going to say it. I ain't mad at the builder for trying to make money, because that's what we're all trying to do ultimately in this world, is make sure we're taking care of ourselves. Now, I wish that builders would be a little bit more thoughtful sometimes. It shouldn't only be about the money, but let's be honest, that's what they're in it for, money. And so when you tell a builder, you got to be all electric, now they may try to leverage the IRA monies and utility monies in order to get better systems. But even those better systems, again, they have to be designed and installed properly in order to get what we were looking for. Now, when we looked at this in terms of, the carbon index and stuff like that, there was a huge disconnect in terms of cost of, moving from a gas home to an electric home. It was like 30 to 100% more cost. Depending on where you were. Now, there's a few areas of the country where that's maybe not quite so extreme, that maybe, the cost per BTU and the more moderate climates, places like Washington State. Washington State, actually, electricity is relatively inexpensive. And so, and given the relatively moderate climate there in the heating season, I could actually see it's maybe not that big of a deal there. But like, Tony, what do you think about? You work on a lot of affordable housing projects with Integral. What do you think about this concept that, all these buildings being forced to be electric? Is that really going to meet the mission of affordable housing, or do we have cross purposes here?
Well, it can. Earlier I made the emphatic point that our economy for the past, 175 years plus is based on the hydrocarbon atom, right? But the policies are very clear. And the policies are generally very good. It's just how they're implemented. And the policy really is, we want to move away from an economy based on the hydrocarbon molecule to one that's based on the electron. Seems like a good idea. The carbon rating index in terms of ESG reporting and everything you guys mentioned in the last podcast sounds like a great idea. But you hit the nail on the head. We are very much in the Wild West in the building industry. I was on a call not too long ago about a high performance building project, a factory built, modular type of project. And the designer actually came out of the aerospace industry, and he's kind of appalled at the way that industry runs versus the way the building industry runs, right? And, we fly in airplanes. We don't live in them. We don't put our kids in them. We don't put our parents in them. But it seems acceptable. Substandard seems to be acceptable for where we hang our hat at night, right? And where we live. So you're right. Our industry needs to be reined in a little bit. And so let's just try to unpack this a little bit slowly, but kind of move the story along here, right? Our building codes, in particular the energy code, being enforced enough where we are reasonably sure that the building envelopes are performing the way the code intended them? No, we know that's the case. Thank God for HERS ratings, because at least our industry, we're the pains in the necks that at least on some small scale push that to happen and maybe exceed it. So that's a good thing. But even within that industry, assuming that energy codes are being enforced and assuming electrification can be implemented, you're 100% right about when you look at grading of HVAC systems, even if a system is sized properly, manual J, S, and D are done. Are they done properly, or are they done just to appease the building permit application? We all know if you really want to drill down on anyone's manual J that you review, you're going to find mistakes in it. It could be an air infiltration level. It could be an insulation level. It could be a window, a shading factor, an orientation, all of the above. Okay.
Yeah. Temperature conditions. Yeah. Ventilation rates. Yeah, absolutely.
Right. And then to your comment about high static and high power consumption on air handlers, how did the manual D get done? Did they actually use the right fittings that are going to be installed in the field, or did they use the best possible ones to get a low static number to match to their air handler, but it has nothing to do with the...
I don't even think one was done. That's the whole thing. Like I have a hard time believing it, so we were there to teach a class, and ahead of the class, I always like to say, hey, if they did an HVAC design, please send it to me. And it's always very telling me that almost every class I've ever done, they can never really send me the design. Sometimes I've gotten it like the day before, and I'm like, okay, like this house is already built. So, I don't know that this is a uniform standard of practice yet. Even if people are doing it, oftentimes, like you're saying, a code official might take it and be like, okay, you did it, and that's the energy code. It's in my file folder. Go do whatever you're going to do.
That's right. So what are the consequences of this? Okay, so you have, substandard building envelopes to some degree, maybe a big degree, maybe a small degree. You have mismatched, maybe, I don't think oversized is the right vernacular to use anymore now that we're into this heat pump, but it could literally be undersized, or there could be redundancy that you don't need. We still see loads sent to us with equipment selections that have 100% electric backup, because there's some designers out there that just still, their confidence level on cold climate heat pumps is back in the 1980s. Okay, where they have full gas backup or they have full electric resistance backup. They have no confidence in the equipment, and they're not considering how tight the building envelope is, or even what the building envelope is, in the right context. Okay, so it's a little bit of a mess. So yes, this rush to electrify, just hit the air source heat pump button. That's the easy button. It gets you your rebate. It's what I have in my warehouse. I can do it. The cost is relatively reasonable compared to conventional heating equipment and air conditioning equipment. You throw in the utility rebates, the state rebates, the tax incentives through the IRA. Everybody's happy. We go on for 20 years. What does this do? Well, in the retrofit market, it could be misleading to people. In the new construction market, you could have buildings that don't perform the way they're intended. But from an electric supply and demand issue, what does this do? It exponentially grows the demand on our grid to the point where the capacity is not there to serve it. And we're just talking about electrification of heating and domestic hot water. We're not talking about electrification of cooking and electric vehicles and those demands that are placed on the grid. And here's a hint for everybody. Those nice new meters that are being hung on your house, those new smart meters that give you your load profile, they are not there for you as a consumer to say, oh, wow, I can see when my house is operating. They're there so the utility can charge you based on demand and consumption during peak hours, essentially setting you up for real-time pricing. So during hours of peak demand, which here in New York, the highest peak generally for the state in general is a summertime air conditioning load. But as we add more heat pumps, and as we add more sloppily installed heat pumps and more electrification, that peak is going to shift to two peaks, one in the summer and one in the winter. And you're going to pay dearly at those hours because you have a deregulated wholesale and retail energy market. It's the law of supply and demand. When you have a short amount of supply and a very high demand, what happens to your cost?
What about, Tony, I'd like to ask you a question about, like, we've been talking, actually, Chris and I, a lot about electrification, As you know, you listen to the cast, and I appreciate that. But just with like electrification of the automobile industry, there's talk of, the grid would have to double in size just to be able to meet the capacity of the American market, to do it, say, by 2035 or 2040 or whatever. What do you think the realistic strain would be? Say the United States by 2035 goes, complete electrification and new construction. What do you think, or how do you think that multiplies the grid demand? In your best guess and with your experience, what do you think that looks like in a long-term scenario?
I was just looking at some information. I know here in New York, it's forecasted to quadruple the electric demand.
Quadruple.
Yeah, I just brought up an article here, gentlemen, from Reuters 6 months ago. New York power grid strained by rapid electrification, operator says. And basically the punchline of the whole thing is that the grid needs to triple its clean energy supply to meet emission-free electric system by 2040. And that was, I think that was before this mandate came out for new construction too. So this is just now the grid is being strained, apparently. Talking to Pasquale, Tony's partner at Integral, who has been doing a lot of more grid scale research about what's going on in New York State and, some consulting. I mean, basically, there's a pretty significant project going on in order to link New York City with Canada in order to basically help to manage the peaks of electrification in New York City alone. And that's just like New York City. Am I wrong about that, Tony, or did I hear that right?
No, you're not. Let me give you some context about this. So the New York ISO, prior to adoption of this mandate, statewide mandate to electrify, but the New York ISO, the independent system operator, was well aware of this, and they released a study back in July. And remember, I said earlier that you have areas like New York City that are considered a load pocket where they need in-city generation because they literally don't have enough extension cords running to New York, right? So I'm going to get back to answer your question. The generation sources in New York traditionally had about an 18% reserve over capacity. And that was always a mandate from the state because stuff happens. Generators break down. So they wanted that 18% in-city reserve capacity just because stuff happens. We've seen all kinds of things happen in New York in the past 2 decades, from terrorist attacks to biblical hurricane floods to outages, you name it, it can happen. So that's why they want that in-city, generation source. The New York ISO basically has said they've gone from an 18% reserve in city to a 250 megawatt deficit by 2025 at the current rate. Coupled with the fact that part of this rush to electrify is the rush to have renewable generation sources, and they have emission standards on many of these plants. And you have basically 2 types of plants in New York State. You have baseload plants, which are the big ugly power plants with the smokestacks that people see and hate. And then you have peaker plants, which are kind of older, used to be baseload generators, a little bit smaller, and you have jet engines sprinkled throughout New York State. Those peaker plants can be dispatched quickly during periods of high demand. Many of those peaker plants do not meet the new emission standards. And so the owners of those generation assets have to make a very important decision. Do they invest the money to clean them up so they can continue to be peaker plants, or is it cheaper to decommission them? They're being decommissioned in terms of renewable energy being connected to New York's grid. Plants are being commissioned at a rate of 2 to 1.
Wow.
So for every 1 megawatt of renewable power being put on New York's grid, 2 megawatts are being shuttered.
Wow. Holy cow.
Okay.
That's crazy.
Yeah. Holy cow. So I want to firm this up. A lot of the work that Pasquale has been doing with New York Geo, and again, I do not for a minute want to come off sounding like a brain on this. He spent a tremendous amount of work doing this. And he really should speak for himself. I know he could.
Yeah, I want to have him on the cast at a later date in order to talk about it. We did invite him to come on, but he couldn't make it today. But
So the work that they have done in monitoring, not just guesstimating, but the work that New York Geo has done, and specifically the Pasquale has done with 2 or 3 projects, and one in particular, there was a Buildings of Excellence project in New Paltz, where they did ground source heat pumps. Okay. And they did ground source. You know, you have this argument, air source, ground source, you know, which one is better. But again, like that first, you know, back in 2002, when I first saw the stack effect chart and the light bulb went off, the notion that geothermal or ground source heat pumps should be looked at as a thermal storage system, as opposed to an air source heat pump, which is not. Air source heat pumps heat when the ambient temperature drops, the efficiency drops. The ground, however,
and therefore constant. The consumption increases. That's the key takeaway. So it's not just that your efficiency drops, it's that the consumption increases.
And the demand on the grid increases. And you multiply that by hundreds of thousands of heat pumps. And what does that look like in terms of a spike on the grid when the temperature falls, right? Especially in load-constrained, load pocket areas like New York City. Okay. Ground source heat pumps, however, because of that constant ground temperature, you basically have pump energy. The pump energy is constant, regardless of what the temperature is doing outside, because the ground temperature doesn't change.
Right.
The loop temperature is more or less constant. And so the demand on the building, yeah, it increases because you may have fan coil units or fan power that's distributing the air throughout the building, but that is very small compared to the high demand for the base load heat. And he actually has data to back this up, and I don't want to steal his thunder at all on this.
We're talking a little bit at a high level, you know. So for those who are relatively new to the industry here, basically think about it this way: you know, a compressor sitting outside, or condensing unit, the outdoor unit of you know a heat pump system, you know, is going to experience the full range of temperatures. And so when we want to keep houses, we're just going to say 70 degrees, you know, for the sake of argument. We want buildings to be 70 degrees on the inside. So, you know, hey, when it's 40 degrees outside, that's not so bad. That's close to the AHRI rating, you know, for heat pump performance with HSPF and capacity. It's not so bad. You know, they operate relatively efficiently at a not so extreme outdoor temperature. But as the outdoor temperature continues to go down, it's harder to wring out those BTUs. That compressor has to do a lot of gymnastics in order to wring BTUs out of the air in order to get, you know, compressed heat back into the refrigerant, basically, you know. And so and then you start going down to, again, you know, Tupper Lake. Most of y'all have never heard of it. It's up in the Adirondacks. Most of y'all have never heard of that. It's up in that thummy region of New York State. You know, it's an empire state, remember? And so, you know, it's got all these different geographic regions. So if this is New York State, I can do this because I'm from Michigan, so I do this all day long. But this is kind of New York State here. And so Tony's down here, you know, down in the Hudson Valley. Sandy's from out here, surrounded by the water, out here on Long Island, basically, you know. And I got buddies up here in Buffalo, Raiders up here in Buffalo, out in you know the western region of the state. Here's the Adirondacks. It's cold up there. It is both mountainous as well as geographically north, and so it's real cold. So when we're talking about, you know, the home builder in Tupper Lake building a new construction house, you know, in 2026, and all of a sudden they're a builder. They want to get this thing done and they want to satisfy their customer, but you know, and they're going to be relying on the local trades too, who they don't have this experience. They've been using with, you know, propane and oil systems and things like that forever, you know. So now they're having to basically figure out how to do this with electric systems. So, you know, all of a sudden, the idea that you're going to have a compressor out there dealing with 0 degrees or negative temperatures in a place like the Adirondacks that's not like ridiculous. That's actually fairly commonplace in the winter time that would be happening. Now, here's the good news. There's not that many people who live in that far region of New York State. But still, it makes a very big peak demand. In order to get those BTUs into the house to keep it 70 degrees, that compressor has to work really hard, and there's more consumption. Versus what Tony's referring to with some of the research that Pasquale has done, the ground is like always 55 degrees. So, you don't have a compressor. What you have is you have a steady source of temperature that is pretty much the same temperature, and it's more moderate. The delta T is a lot smaller. To go from 70 to 55 is small. To go from 70 down to 0, that's big. I gotta expand my range here, and so it makes the consumption a whole lot higher. So part of what, when Pasquale told me he was working on geothermal stuff, I'm like, man, that's for big buildings and the rich. And he was like, no, you have to start looking at this because this could be part of the solution. If New York State or any other part of the country wants to really electrify, and we don't want to triple or quadruple the capacity of the grid, it may make sense to treat more of the ground as that heat exchange source. And that actually made a lot of sense. Like the light bulb really went off, because if you start looking at like the cost of tripling the grid, versus the cost of, drilling some wells and, and having people, do horizontal loops and things like that to have heat pumps or, ground source heat pumps, it actually starts to make a lot more sense. And so I appreciated that perspective from Pasquale.
And I think the cost part of it is, oops, sorry, Tony, go ahead.
Go ahead, Seth. No, go on.
No, I was just going to say the cost component of it's a big part of it, right? I mean, you're talking about trillions of dollars nationally to expand the grid, just on a double or triple, size. So it's like we have to start really thinking about alternatives, because it is great to go to electrification, but I don't think it's not going to all be government sponsored, and there's going to be rate hikes and things like that involved to get this. And I think we really have to start sprinting towards these solutions like ground source, heat pumps and, alternate ways, and making sure like things are designed highly effectively and highly efficiency. I mean, we have to do that now. Like it's not tomorrow, it's not next week. You know what I mean? So I think all these points are great. Tony, go ahead. I'm sorry about that. I didn't mean to cut you off.
No, it needs to be done yesterday, and all the credit goes to Pasquale and New York Geo in particular, because they have actually gone to the New York Public Service Commission, which is the governing body that sets rates for water, cable, telephone, and utilities, and made the case with the Public Service Commission, and very favorably. It was accepted and understood very favorably that one way to mitigate some of the strain on the grid and to lower the demand on the grid is wide-scale adaptation of ground source. And it can be a single-family solution, and it can be a multifamily and commercial solution. One of Pasquale's, buddies / client, Anthony Abbey, who continually wins the cross-border challenge with Net Zero Now, has exclusively built zero energy certified homes with ground source heat pumps for the last 10 years. He's one of the only developers in New York, well, at least in our part of New York State, that's doing it. That's what he builds, nothing less.
And I was at Build NYC this year, and I saw some really interesting new technologies with ground source heat pump too, where you don't really with tight places like New York City, where they can drill down and out almost like in a cone fashion instead of using the traditional type of drilling, which takes less space up but gives you the same results. And I mean, there's been some really exciting, advances in that technology,
Yeah, the market itself, the industry, I should say the geo industry itself has done itself a good service, because it is now, it's mature, it's professional, and it's integrated. It's not fractionalized with, you hire a contractor, and it's generally, not in all cases, but generally turnkey. The engineering of it, the sizing of it, the loop flow calculations, the well calculations, the load on the building, and to some degree, the implementation of the equipment installation is all integrated. Now, you still have sort of the downstream side of it, which is the air side of it, which is still subject to some of the, nonsense that we see with workmanship, right? But a lot of that because those projects are kind of monitored, is going away. You're seeing a very wide variety of projects in New York City going to ground source or geothermal. St. Patrick's Cathedral, they converted over. They're 100%, geo. A lot of buildings. In fact, they one company in particular, I think they do work with one of the geo companies that's part of New York Geo. They just got I want to classify it as like a mineral rights. Like if you drill a well below 500 feet, you actually have to have like a mining license. And so they sort of did away with that so that they could drill deeper wells in Manhattan. And you got to think about it. You poke a hole in a street in Manhattan, not only, it's this Manhattan schist, which is this ridiculously hard rock, but you peel up the streets of Manhattan, sometimes you've got 3 stories of utility infrastructure under there.
Yeah.
You've got steam mains, gas mains, cables, all kinds of stuff. I mean, it's literally like threading the needle when you drill in some of these places. So you really have to do your homework. So if it could be proven in a market like New York City or any big metropolitan area, it could be Boston, could be Detroit, wherever, you're really doing something for the business. But the fact that they were able to actually show the Public Service Commission of New York the results of monitoring a building for over a year and how it really not marginally mitigates the demand and strain on the grid, lowers the cost. It's huge. It's really, really huge. And I think the DOE, Pasquale just shared a report with me earlier this week. The DOE just came out and did a big study, and they formally recognized GEO as a widespread, if GEO were adopted in a widespread manner, it is one of the single most mitigating factors for lowering the grid and allaying some of the fears of all-out electrification, at least for heating and domestic hot water, right? We still have all the other stuff to deal with, cooking and EVs and all that. But if we're going to try to keep the load growth in check, this is the way to do it. I'm convinced.
Well, and Tony, honestly, you just said something too that I'm gonna pick on here, which is, we're not talking about cooking and things like that. I got to be honest. I think our industry needs to stop it with the whole cooking thing, and it's not that I think that it's like, I believe the science. I believe that there's more, particulates or, methane and stuff like that with natural gas cooking. I get it, but we're ignoring the bigger problem at the expense of focusing on something that's actually extremely simple. Heating loads, addressing heating loads is the thing we need to be doing. That's the biggest thing. That's why when you talked about, is the energy code actually being implemented? Are the building envelopes actually what they need to be? Because here's the thing. If we had more robust building enclosures where we smash the heating load, maybe this would make more sense. And I think that that's part of what's going to happen because, going back to that article about, the implementation of this new rule in New York State for electrification, it's going to be implemented as part of the energy code. And so, the energy code it's going to be something like a 2021 or 2024 flavored code. So it's going to require better building enclosures. And so, if that is implemented, and again, that's the big if, right? You already sort of talked about, whether it is or not. But if it is, then that will make a pretty significant difference in terms of lowering that heating consumption. I almost wish that our industry, I just got to admit it, for all the amount of times that we talk about hugging heat pump water heaters and kissing induction stoves because it won't burn your lips and stuff like that. I wish that people don't actually do that, do they? I made that one up right there, but I'm going to start doing that. Let's kiss our induction stoves.
It's lonely,
for all this, I think we're focusing on the wrong thing. I'm going to tell you all, do whatever you want, but just stop. In my opinion, stop it. Stop with this penny ante stuff because Tony's got a lot of experience here. He's operated as, a grid level manager. The problem is if we do this wrong, the big thing, the smashing the heating loads, the picking the right designed systems to meet those loads, we are just going to royally screw up. What's the consequence, Tony? I mean, what happens if this is done? What happens if business as usual? So like poor implementation of the energy code, fat fingered at best HVAC designs, poor implementation in the field, and the wrong system selections, like inappropriately performing air source heat pumps. What is the consequence if that is what gets implemented starting now and into 2026 and beyond?
Well, I call it the compact fluorescent light syndrome. Okay. What was the big knock on compact fluorescent lights when they first came out?
Their light quality sucked and they looked ugly. I don't know,
Well, yeah, I would tell you that from
cold, they take a long time, right? So for an entire generation of light bulbs, CFL sucked because the first generation sucked, or they were manufactured, to substandard, or whatever. That's history is going to repeat itself, and it's going to repeat itself two ways. What's going to happen is heat pumps are going to suck. Not because the heat pumps suck, but because the installations and the sizing methodology suck. And oh, by the way, it's going to have a halo effect because people are going to lump heat pumps in one big basket. They're not going to differentiate air source from ground source. Heat pumps are going to suck. Also, I can say this because now I'm old. During the 1970s, there was a concerted effort to electrify. There were a lot of public housing buildings that did away with their old coal-fired boilers that put in electric resistance heat because electricity is going to be so cheap with nuclear energy, we were going to give it away. Did that happen?
You mean that $1 billion+ we spent on Long Island out in Shoreham that never got built? Is that what you're talking about?
Right. So that never happened. So electric heating sucks because people have long memories and they don't get the full story. They just like to hear they want the little soundbite bad news just so that they could talk about it around, where the water cooler or whatever, right? So that's my fear of where this industry is headed if we do this wrong, is that you're going to have this momentum because people love failure, They love to talk about the failure. They love to give a bad review at a restaurant. They love to knock a heat pump when it's not doing its thing, right? And they'll hang on that, and that momentum will just carry through a generation. What we really need is for people to understand, and I'm part of a business advocacy group here in Rockland County, Rockland Business Association, and we talk about this. We've actually had representatives from the New York ISO on to talk to the business community. We've actually had people from New York GEO come in and talk to the business community about this, mitigating load, because they're professional real estate people that are selling all manners, Class A, B, C, D buildings. They're developers of affordable housing, commercial spaces. They need to know what the status of energy is in their state and in particular in their county. This has big, big, big repercussions if we do it wrong. And unfortunately, I'm going to say some things that may not go over well. We've got a generation or two of people in the building industry that are grossly lacking any sort of education. And I'm not talking about college education. I'm talking about good basic building science education, okay, on how this stuff works. The elephant in the room is exactly what Chris said. It is heating. In fact, one of Pasquale's slides, they have a slide of literally a big elephant in a room with heat on its butt.
That's part of what I was referencing was Pasquale's slide.
So
I mean, awesome. Yeah.
Mm-hmm. I think, so you're right. It's there. The heating demand can, if we do it right, we can have renewable energy in our grid, which is going to take a long time to build out. If we transition it right and we do our buildings right and we do the building envelopes right, match the heating systems properly with the right heating equipment, implement it properly, it'll be kind of smooth sailing. Now, we've talked a lot about the bad and the ugly. Let's talk a little bit about the good. Okay. As I said, the DOE has recognized and sort of, admitted GEO as a solution and is, I guess, in a position to sort of advocate for more widely adopting it. The practitioners of the GEO world are out there. They have their big boy pants on now, from the engineers to the installers. It's more integrated. That's good stuff. The building codes have been a bit of a carrot and stick situation, or at least the energy code portion of the building code, has been a carrot and stick. You see states like Massachusetts that have very robust incentives at the utility level, state level, even tax credits that reward high performance building enclosures, right? Getting HERS rated. I think Massachusetts has done it the right way. Our state here in New York, not so much. It's been heavily slanted towards the low moderate income side of things, not so much on the market rate. They've heavily incentivized a very small percentage of the actual built environment.
True.
I think more needs to be done. And so there's a little bit of a failure point there. But assuming that we can get our building code officials, our builders to do building envelopes right, where you actually do have reduced heating demand load and match the equipment properly, do that sizing right, then this can really work. Chris, you mentioned the fact that essentially there's going to be an extension cord run from Canada down to New York City. That is actually a DC power line. It's called Champlain Express. It's 1,000 megawatt extension cord from Hydro-Quebec. So Quebec apparently has a lot of hydro energy. By the way, New York State does too. It was all built during Teddy Roosevelt's reign as governor of New York. To this day, it still represents about 20 to 25% of the generation capacity on New York State's grid. So it's no small part. So when you see big renewable numbers from New York State in terms of generation capacity, it's great, but some of it's 100 years old. Okay. Some of the offshore wind power plants are actually being built, and I have some questions about that. But the very first offshore wind turbine went online this week off of Montauk Point. So that's one project. It's going to be 130 megawatts, roughly 12 or 13, wind turbines. So the first one went online. Supposedly is now, supplying energy into the grid via Connecticut for the Cross Sound, line into Long Island. Okay, so that's kind of good. The load this week in the New York control area, or the New York ISO's area, was about 14,000 to 15,000 megawatts statewide. And we actually had double-digit renewable generation. It was actually about 11%. A large portion of that was wind this week. So that's some of the good stuff. You couple that with the fact that we're still closing some of these peaker plants and baseload plants at a more rapid rate than the renewables coming on, but the stuff is coming on. It definitely is something to keep an eye on, because the interest rates and the inflation, supply chain issues that we've seen in our industry are affecting this too.
No doubt.
New York State's trying to renegotiate some of these offshore wind projects, because the developers of those projects are coming back and saying it's too expensive, we can't build it.
Well, we saw what happened with that one off the coast of New Jersey. I mean, that one just got killed, so.
Two of them, and it's the same developer that's doing the ones off of Long Island, which is a Danish company, by the way. And so that's maybe a podcast for another day. Why are we investing money in not that, Denmark is an enemy of the United States, but why are we handing billions of dollars to another country to build our energy resources, which are arguably supposed to be more secure and better for national security than buying oil from Saudi Arabia and Venezuela and Russia, right? So, we need to look at that and maybe talk about that over a beer someday, okay? So the good news is...
that's a good point. We need more beers on the Bearcast. What have we been doing here, Sandy?
Change it
next time, Tony. Beers.
Next time.
There you go. So, there are wind farms in upstate New York. There are solar farms in upstate New York. So the percentage of renewable generation that's coming on is increasing, albeit very slowly. This 1,000 megawatt, DC extension cord from Hydro-Quebec is supplementing existing hydro power that's come from Canada for like over 40 years. And there's also, New York is not an island, electrically speaking. It's interconnected with other grids, PJM to the south and west, the New England ISO to the north and east. And they all share, generation. It's almost like mutual aid with a fire department, okay? Different firehouses will cover another firehouse if they have to go out on a call. It's the same kind of thing. There's grid injections from other ISOs into our region and vice versa at times of peak demand. So some of that, the grid is very much elastic in that way, and it's interconnected. And even with Canada, we share electrons with Canada, and very widespread. Your area, Chris, the regional ISO for your area, it's actually an RTO, I think goes from your state of Michigan all the way down to Louisiana. It's a whole swath of the middle of the country, and there's one grid operator for that entire area. And so they're able to dispatch generation sources over a large. So with some of this money that's coming from Washington to bolster our transmission infrastructure, and some of the private investments in offshore wind, onshore wind, and solar, it's coming. It's going to take a while. Can we bridge this gap from the mandate to no more fossil fuel to get to where we have these double-digit, renewable generation sources? Can we make it? This 20-year period is going to be really interesting to see how we do it. We have a great opportunity to do it right, and I think our industry, the HERS industry, now with the carbon rating index, we're sitting pretty. We have the ability to do this. I still think our industry needs a very high-level spokesperson to really get the message out to builders and codes. I early on I said
100% agree with you on that. I 100% agree.
Steve Thomas from this old house that was the face of BPI for a period of time. I don't know what they paid him to do that, but we need somebody like that for the HERS and the built environment and the high performance building industry. We really do.
Yeah, I think you're right, because, don't get me wrong. I mean, I like all my colleagues in this industry. I think everybody is really trying to do the right thing. But this whole, me making fun of, kiss your, heat pump water heater and stuff like that. Now imagine if we took all this same money and said, now everybody do a passive house level building enclosure. And we're going to incentivize that. That would be a durable physical asset that would last for potentially, 50 or 100 years. And it would probably be the same amount of money, roughly speaking, as the kind of money that we're putting into equipment, which is transitory. It blows out every couple of years. So even if you do it well the first time, it's going to be gone in 20 years. And
well, that's it. I mean, look, what's the cheapest energy you can buy?
Stuff that you don't use.
Exactly.
And so I guess, so somebody who's kind of like, I like to go back to basics. Like, why aren't we focusing more on that? Like, again, I'm not against electrification. I think it is the way of the future. I just don't know that the future is within the window that everybody wants it to be. I think that I think
that's a good point, Chris. And we brought this up in other podcasts that the concept of it is wonderful. It's the right way to go, but the time frames are just way too tight. And I think that we have to figure out a way to stretch this out into reality so we can actually, the great ambition can meet the actual reality of what needs to happen. And I think, we've pointed out on a couple of the podcasts about this. It's like, stop putting these unrealistic dates on it until we have all the information, and let's take steps, the right steps towards making this successful.
Absolutely. And it's very much regionalized. Almost each state has to kind of look at that and kind of come to grips with it. And so, Chris, I very much appreciate the sentiment with FEOS is an obvious solution, right? You're talking about, 60 to 80% reduction on your peak heating. I mean, that's a no-brainer. That's a one-time capital investment in your building enclosure, and the rest of it is that energy you don't need, right? It's there as supplemental heating. You're really dealing more with the internal gains and cooling and comfort in the summertime than you are with heating. These buildings will heat themselves, right? We know that it's proven, it's got a track record. Let's keep a close eye on what Massachusetts did with their stretch code, okay? Where they basically the municipalities that adopted that stretch code, every building over 12,000 square feet has to be passive certified. Pick your flavor of passive certification. We know which one I'm biased towards, but that's okay. Fias, shameless plug. But the bottom line is it's two different ways to get there with that large, reduction. Let's do that, right? That's absolute. We have that in New York stretch code as an alternative compliance path, but it's an alternative path. Not to
what we need is a slogan. We need a slogan that sounds a little bit more, because you say electrification. Oh my God, like that sounds great. Replace your furnace with a heat pump. Like all these things sound so good, and they're like you can wrap them around in a real simple package. It's hard to do that with robust building enclosures. Like that's the thing that we got going wrong for us. It's like I don't know. So we got to talk about that at a different time. Tony, I really appreciate you coming on the cast and
this was awesome,
to
Tony.
Rap with us. You're giving us a dose of reality when it comes to these bigger decisions. And the good news, I take it you're optimistic.
I am. You take small bites of this, right? I mean, we're in some ways we're still fighting some of the same battles that we did, 20 years ago when I got involved in this, but those battles are far fewer. That's kind of nice. The beauty of it now is as we sit here at the end of 2023, with 2024 literally 2 weeks, 3 weeks around the corner, the means and methods to do what we need to do exist. We're not saying we need heat pumps to do this. We need insulation materials, but they don't exist. It's all here.
It's true.
Go to a supply house. Go to a home center. The equipment's there. The materials are there. We know how to do it. What we really need how to do is realize, as much as we're, sort of geeky technocrats in the HERS industry, we got to realize we're in the people business. And the communication and education piece really cannot be underscored. We have to let people know the realities of what we're facing in terms of electrification and where the built environment needs to be, the aptitude level of the guy swinging the hammer, where that person needs to be, right? And we gotta drill down on that hard.
And everybody in between. I agree with you 100%. I love that sentiment, Tony. Couldn't say it better.
Knowledge is power. All right, y'all. So we're going to go ahead and wrap this up. Thanks very much for taking a listen. Tony, thank you again for being a great guest. We're going to just go ahead and put a bow on it. This one, we've wrapped long enough. Thank you so much for taking a listen to the cast, and we'll catch you for the next one.
Thank you, Tony.
All right. Happy and merry, guys.